I'm James Johnson, and you're watching Niagara Pro Tips. Welcome back to this series of videos on the Niagara Cloud Suite. This is part 5 in the series. You need to make sure to take a look at some of the previous videos which covered things like project setup, onboarding a station to the Niagara Cloud Suite, and setting up authentication and service accounts. This video is going to focus on using the NDS APIs, and it assumes that you already have a service account set up in your Niagara Cloud portal for your customer, and we're just going to be talking about the APIs themselves. On the Niagara Resource Center, you'll notice that there's a tile for Niagara Cloud, and when you click this link, it takes you to tiles here for all things related to the Niagara Cloud Suite documentation. And specifically, we're interested in this NDS API guide. The NDS API guide is going to give you details about the different APIs that are available, and they're broken down into the EMS, Egress, and Control API currently. I'm going to focus on the EMS API support first, and then also talk some about the Egress API support. There'll be another video later on that focuses on the Control APIs. The EMS API is the Entity Model Service, and it's designed to allow an application to query the Niagara Cloud Suite and query for things that are stored there in the semantic model. So when things like drivers, devices, points, histories, things from the station which have been modeled into the Niagara Cloud Suite, and these external tools can query about those. We have a couple of different ways that we can query for information. One is by point name. You can also query based on tag names of tags, metadata, semantic modeling that's applied to things in the station, or you can also query based on the value of specific tags that are applied to the components in the station. And whenever we're doing these queries, we're going to need some key pieces of information to help us understand that. What the request is, what kind of data is for the customer, and so forth. The customer ID is going to be one of those key pieces of information that we'll need to know about. The easiest way to find your customer ID is to log into the Niagara Cloud portal, which I've already done in this case, and select one of your customers that you're interested in using the NDS APIs with. Once you click on the customer, you'll notice in the URL field up here, the end of that URL will contain the customer ID. So you'll need to jot that piece of information down because it'll be utilized in some of the EMS API requests. Now, in the NDS API documentation, I'll go through and show you here in the documentation about the information on the APIs, but I'll also point out that there is a hyperlink in the documentation to this Swagger UI. And when you take a look at the Swagger UI, you'll see that this also includes information that gives you information about the query parameters, the URL path, and what the HTTP post body needs to look like, and what responses will look like as well. You can even try it out here, but you will have to click the authorize button and paste in a bearer token that you've obtained from the auth.ping1.com server. In this case, I'm going to stick with the API documentation to talk about things, and I'm going to show you using Postman how to do some of these API calls. So in the documentation here, we'll see that there's a search criteria, and when we click on this link, this is going to show us some more of the information that we need to know about in formulating our request. One thing is going to be the system GUID, and this is the unique identifier that identifies the station within the NCS portal, and that gets generated whenever you onboard the station. So easy way to find that is in your Workbench client, connect to the station. Under the services, go to the Niagara Cloud Connection Service and look at the RPK Authenticator. The system GUID will be displayed here, and that will be used in your HTTP post requests and the body, and you'll need to know that information. Now, I mentioned that there's some different APIs here to query. We can query based on point names, we can query based on tag names that are assigned, and also the value of specific tags that are assigned. And when we're doing these searches or these queries, we can specify the comparison type that we want to utilize. You can use an any comparator, exact, starts with, ends with, or contains. And I'll show you a little bit more details on another documentation page in just a second for that. We'll also have search items, and the search items are going to be really an array of strings which are helping us filter the things that we're looking for. When you click on the search items help topic here, you'll see that it gets into a little bit more detail about what each of those search comparison types mean, and also the fact that they're going to be case sensitive with the exception of the any comparison type. You'll also see some examples here of different bodies for the HTTP requests for the post. You'll see examples doing point name API calls, or tag name or tag value API calls. And I'm going to get into a little bit more detail about what these look like. To do that, I'm going to utilize Postman. And in this case, in Postman, I've got set up an environment, and that has some variables for things like my client ID and my client secret. And there's a previous video that Kyle talks about the authentication mechanisms and gets into some more details about this. So I'm not going to cover that in a whole lot of detail. But I have a collection here, and this collection is set up with bearer token authentication. And it utilizes a variable here in Postman, which is where my bearer token gets stored. There's a script on the pre-request on my collection here, and what this does is it goes out and it contacts auth.ping1.com. It sends my client ID and secret, and it obtains the bearer token and stores that as that variable for my request to utilize. I also have some variables set up here on my collection just to simplify things a little bit. So things like my customer ID and my system GUID. So I don't have to constantly type those in, particularly because the system GUID is kind of a long variable or long bit of information there. So that's just a little bit about the collection setup. Okay, so let's take a look at an actual request. In this case, I have a request set up, and you can see that it's an HTTP post, and I'm connecting to the Niagara Cloud server, and then I have the API path, which is specified in the API docs. In this case, it contains a variable pulling my customer ID in, so I don't have to type that in. And you'll notice that this is the point names API, so it ends in point names there. And in the body of the request, you'll see the properties that I'm passing in. So system GUID being read from a Postman variable. My search type is going to be based on point name, and my comparison type is any. So in that case, I don't have any search items. I'm just saying, go search the entire cloud database for this particular system and find all the points with any name. In this case, you'll see that JSON payload gets returned here at the bottom. And it's basically an array. It's not basically, it is an array called point models. And inside of that array is going to be information about the points or components that it found based on that query. You can see that they have a cloud ID tag associated with each of those components, a name. It shows tags that the cloud knows about on those components in the station, as well as relations that it knows about, what the relation is, and the inbound, outbound, and so forth. So all that information is stored there. Now, it's a little bit difficult to look at that JSON maybe and looking at multiple information that's returned. So in Postman, I'm using a PostResponse script here, which once the HTTP request is sent and a response comes back, then Postman processes the response, gets the JSON out of it, processes the point models, and I use that to kind of walk through some JavaScript and build a little HTML visualization. So in this case, I can click on the Visualize tab and just see some information from each of those items that are in the arrays. And I can see that each one has a unique cloud ID, there's a unique name, a unique haystack ID, and it has some information for a few items here. Looking at the actual JSON payload response, we'll see at the very bottom there's a page object. And the page object includes a size, which tells me how many items are in the page, and that's configurable, but defaults to 20. It tells me how many elements it found in the cloud, and then how many pages it takes to send all that information to me. And the number here indicates which page I'm looking at, and that's a zero-based count on the pages, so 0 is the first page. On the request, we can go turn on optional parameters that we want to pass. In that case, the page parameter will tell it which page we want to have displayed, and the size will tell us how many records per page. If I send this request again, we'll see that now if I scroll to the bottom, the size now indicates 50. I still find 828 things in the cloud, but it's being relayed in 17 pages, and I'm looking at the second page, which is index 1 on the page numbers. And if I look at the visualize, we'll see that now I'm seeing different components listed here, and obviously the cloud IDs and haystack IDs and so forth for each of those. Now, Each of these points we can search for based on the name of the point also. And we can change this API call just a little bit. I'm still using the point names API call, still passing in the system GUID and the point name search type. In this case, I'm going to change my comparison type to exact, and I'll include a search items. Now, the search items is an array in square brackets of strings that I want to search for. So I can put a comma and additional point names as strings with double quotes. But in this case, I want to just search for the components in the station which are named room temp. So in this case, we'll get back details about each of these room temp points. And again, I have a script set up for the post response, so I can look a little bit easier at some of the information in a table view. Notice they're all called room temp, but they all have a unique haystack ID indicating which air handler room temp they are, as well as unique cloud IDs. Some of these may have history tags associated with them, and also potentially a Niagara Cloud telemetry ID tag as well. Looking at the raw JSON again, we'll see for a given room temp point that returns the cloud ID for that point, as well as all the tags which are assigned to it. So things like a name tag or a display name or a type tag. If I scroll through the list of the JSON components here, I'll find a bunch of haystack tags as well. And eventually down towards the bottom here, we'll see things like there's a haystack zone air temp sensor marker tag, or a zone air temp and sensor marker tags as individual elements. So instead of relying on the names of the points in the system, we're able to use just that semantic model as well, utilizing the tag names API. So the path is pretty much the same as the point names, but in this case, the end of the URL changes to tag names. My search type then also changes to tag name. I still pass the system GUID, and I'm using an exact comparison here. And then in my search items, I'm using the fully qualified tag name that I want to search for. So in this case, haystack zone air temp sensor tag group. When I send this request, we should get the exact same information as the point name query did. But again, we're utilizing the metadata that's assigned to the components in the station instead of relying on the tag names. So this is a little bit more fault tolerant to naming conventions, assuming that there's a consistent data model that's been assigned to the components in the station. Once I know the cloud ID for something, this is really probably the main thing I'm going after, would be maybe this cloud ID or this telemetry ID. Then this will allow me to query for specific components in the Niagara data service and find out the information about those. So using this tag values API, very similar to the other two EMS APIs, but it ends in tag values. I change the search type to tag value instead of point name or tag names, and still passing the system GUID. And again, I'm still using an exact comparison in this case. And my search terms are going to be for the Niagara Cloud Cloud ID, and I give it the value of the tag that I want to search for. When I send this request, I'm getting back the same kind of information. It's a point models array, but in this case, there's only one element in the array, and I'm able to find just the information for that specific air handler that I'm interested in. So the whole point of the EMS APIs is to allow an application to query NCS and find out what information is available based on a semantic model, find the cloud IDs, the telemetry IDs, so then you can utilize other APIs. In this case, we're going to talk a little bit more about the Egress API support then. And the Egress API support is the Data Egress API. It's designed to allow an application to query the NCS portal and to obtain historical information or telemetry data from the histories that have been archived to the cloud. Very similar to the EMS APIs, you'll see that there are links for the Swagger UI here, and you could certainly go over and take a look at that, and you'll see that there's information about the request body and example responses, and again, you can try it out by authorizing and then submitting actual requests using that Swagger UI. I'm going to continue to kind of focus here in the NDS API document. So with the API requests, then there's a help topic here on submitting your HTTP request for this API, and you'll see that it has the endpoint, the path for the API. It's still an HTTP post method that's going to be submitted, and it's still using the bearer token. we'll see that in the body of that HTTP post, you're going to include things like the system GUID, which was the same thing that we used for the EMS API. And there's going to be a cloud ID property here as well. That's going to be an array of the cloud IDs of the histories that you want to query from NDS. We'll also pass in a start time parameter and end time parameter, and those will control the history records that are going to be returned by the query. There's a record limit property that you can use also. So if you were querying a wide time range, then you might limit the records to only 1,000 and you would get the first 1,000 records. There's also properties for include pre-record and post-record, which means if there's a record just prior to the start time, it'll include that record, or if there's a record just after the end time, potentially it will include that record as well. And then we also have the option to sort the responses. Now, there's also a post properties help topic here, and this goes into detail and explains a little bit more about each of those properties and also shows you an example response there. I'm going to hop back over to Postman, and I have a Data Egress API example set up here, and you'll notice that the API path is what I was showing you in the documentation, and it's still an HTTP post, and then we have the body that we're going to fill in the information on. So again, system GUID is telling us what system that we want to query from in NCS, and then the cloud ID property is going to have an array of the NC cloud IDs for the components that we want to query the history from. We'll also pass in a start time and an end time to our history request and a record limit. Now, all three of these are being passed as variables just to make things easier for me in Postman. I'm also telling it to include a pre-record and a post-record and to sort the results in ascending order. With this API request, I'm also trying to simplify things, make it easier on myself. So I have a pre-request script here in Postman that gets whatever the current moment in time is. And then it's going to format that as a current date, and it's going to store that as a variable called end time on my collection. It then subtracts 30 days from that calculated date, and it stores that as start time in the variables. That way I don't have to worry about trying to encode the start and stop times here manually in the syntax of the body, and it's just going to calculate that and derive it for me as I'm doing my examples. When I send that request, then we'll get a response back from the station, and again it's a JSON payload. It'll have things like a system GUID of what we queried, our record limit, and then there's an array called point details. That point details array, if I had specified multiple cloud IDs here, there would be multiple elements in the point details array. In this case, I only have results for one cloud ID because that's all I requested. You can see the cloud ID here for each item, then it's in the point details array, and it may contain a pre-record, it could contain a post-record, and then it will certainly have a history records array, which will contain an array of all the history records within the time range that you queried. Each of those records will have a time key with the timestamp, a value key with the value, and a properties key with a bunch of property information, which is really trend flags and status flags. So it's giving you information about the quality of that history record and the data that was collected at the time. I've also set up a PostResponse script here as well, in this case just to set up some basic visualizations so that I can look at those records maybe a little bit easier here within Postman. So that's an example of using the the Data Egress API. The EMS API's entity model APIs are to find out information about that semantic model. Now, show you a little bit of an example here in Grafana as well on utilizing the Data Egress APIs. And in my Grafana setup here, this is the Cloud Grafana instance, I have a data source configured, and I'll just show you what this looks like real quick. Kyle has talked a little bit about authentication, or a lot about authentication in a previous video. In this case, I'm using an infinity type data source connector, which is a default connector in Grafana. It's set up for OAuth authentication with client credentials workflow, and I'm passing in a client ID and client secret for my service account. It's connecting to the auth.ping1.com with the NCP read scope. So this will allow Grafana to authenticate to auth.ping1.com and obtain a bearer token. And once it gets the bearer token, it uses that as the authentication for any of the requests. All right. This is an example of a dashboard in Grafana, and I'm going to go into the edit mode on this particular widget. And this widget is displaying a table of information. And you can see currently in the results of the table, there's a point details column here that has an array of a whole bunch of information, and there's a record limit and a system GUID. So this is sort of the top level of the JSON response that Grafana gets back from submitting a request. Here in this lower panel, I'm using the Infinity data source that I configured. It's sending an HTTP post to the Data Egress API for the Niagara Cloud, and I'm telling it to expect a JSON response back from the server. We can click this button here for headers, body, and request parameters, and I can see this is where I go in and configure the HTTP post body for this request that's going to be sent. And you'll see the same kind of properties that I was showing you in Postman. I have a system GUID, a cloud ID, start time, end time, my record limit, include pre and post records, and sort ascending. Any of these items with the $sign are variables within Grafana. So again, just trying to make things a little bit easier on myself, I've stored the system GUID, and I'm reading the start date and end date from this from the date selector up here, so that I can just change it in the dashboard and it'll respond to that. So these are kind of simplifying things with the variables. Now, why am I seeing this table with just 3 columns? If we take a look at the query inspector here and look at the query, we'll see that what Grafana does is it really constructs a curl command and sends that to the server with the bearer token authentication. And we can look at the response and the requests here at the bottom. I'm going to click expand all, and then really just interested in the response at the moment, so I'll really probably collapse the request. And what we can see is inside of the response here, there's a result and there's a data object. And this data object has has elements under it. So this is the root of the JSON response, has a point details array, a record limit key with a value of 2000, and a system GUID key with this value. So that's what Grafana is displaying in the table, are the root 3 items that it sees in that JSON payload. Now, if I expand the point details array, that's where we have arrays underneath. In this case, it's really just a single array because I only asked for 1 cloud ID. And underneath of that are the history records, the point ID, the post record, the pre-record. And if I expand the history records, we'll see underneath that array, each of those items has the properties with the trend flags and the statuses, it has the time, and it has a value. So we need to try to tell Grafana how to parse this response from the Niagara Cloud. And we can do that using the parsing options here at the bottom. This allows me to put in a JSON path selector statement. And with JSON paths, the $sign character represents the root of that JSON payload. And then I could do something like point details here, and that will cause the query to refresh in the table. And you can see now it's narrowing it down to the point details array, which has 1 item. So there's still only 1 row being displayed, but now it's showing a history records column, a point ID column, a post record, and a pre-record. We can narrow it further with the JSON path selector and tell it to narrow into the history records array. And then I can use square brackets and an asterisk to tell it to display all of the rows in that history records array. So now I'm getting down to the point where I'm seeing that history records array being displayed here in Grafana, and I have the properties column, and I have a time column, and a value column. We'll see that the time column is actually being displayed or processed as a string, so it's not really a timestamp, where the value column is being processed as a number. And I probably don't need to display the properties column here, so this is where I'm going to use the add columns function, which is sort of like the projection in an SQL statement or a BQL statement. So we want to tell it which columns to show and how to format those columns. So in this case, I'll put time as the column I'm interested in, and the title might be timestamp. And I know it's a string, but I want to format this as a time. And when you do that, you'll then have options on how that time is encoded. And in this case, it's using the default ISO, and the auto settings should pick that up fine, but you could configure that if you needed to. And that would only show the timestamp in the table. So I would also need to say that I want to show the value and give it an alias as well, maybe. And then Obviously, I don't need to convert the format, but in this case, I just need to say it's a number so that it will display the values in the table here. So now I'm getting timestamps and values from that request that are being displayed in that table view. Within Grafana, you can then pick different visualizations. So if you wanted to show things as a chart instead of a table or something like that, you certainly can. In this case, I'll just save the dashboard and then go back to it, and we'll see that I have tabular data that's coming in from an NDS API request, and I also have a chart here that's visualizing that same information that's also using an NDS API request. So I hope you found the video informative, and it'll get you started with using the EMS and Data Egress APIs. And stay tuned for additional videos in this series focusing on the control APIs, the Niagara Cloud Portal UI, and other features and functionality. Thank you.